Hello friends, now we are going to start the chapter 4 probability of algebra. Now this is one more very simple chapter. Okay. Now what is probability? You might have heard that we say sometimes in IPL maybe the Mumbai Indians will win. Maybe the Mumbai Indians will win, or probably I will get good marks in some exams. Now we just predict all these things. We don't have any command on that. That means we are not always sure that this will happen. That is why we say probably this may happen, or probability of this event is very high. Now where this word comes from? फार पूर्वीच्या काळापासून गॅम्बलिंग मध्ये या शब्दाचा उपयोग व्हायला लागला. फॉर एक्झाम्पल, सपोज आय एम अ गॅम्बलर आणि तुम्हाला माझ्यावर बेटिंग करायचं आहे. ठीक आहे ना. आपण इव्हेंट असा घेऊया की टॉसिंग अ कॉइन. नाउ वी नो दॅट द कॉइन हॅज टू फेसेस, हेड्स और टेल्स. नाउ सपोज इफ आई टॉस कॉइन 10 times and say heads, and 9 times the head comes. Okay. Now do you guarantee that on the 10th time also the head will come? No, absolutely there is no guarantee. Similarly, in many conditions, even if the 99% events are in your favor, it is not guaranteed, or it is not necessary that 100th event will also go in your favor, because there are n number of factors affecting on that. Sometimes we call it as luck, and the luck, this word was used in the gambling field the most. So let us see one more thing. Suppose there are two persons, person A and person B. Now you want to bet on these two persons. That means these two people will toss a coin, and the whole game of gambling will based on this. Okay. Now on whom you will bet? Past record, त्यांचा past record असा आहे की A नी जर का 10 वेळा कॉइन्स टॉस केलं तर तो 9 वेळा करेक्ट असतो, आणि बी नी जर का 10 वेळा कॉइन टॉस केलं तर तो 4 times करेक्ट असतो. ओके. आता बघा, गॅम्बलिंगच्या गेम मध्ये किंवा कॉइन टॉसिंग मध्ये कोणीही हे सांगू शकत नाही की हेड्स येईल किंवा टेल्स येईल. हे कोणीच सांगू शकत नाही. जर का सांगितलं तर ते एक लक असतं, ते एक प्रिडिक्शन असतं, म्हणजे चुकून आलेली गोष्ट असते. तुम्ही बोललात म्हणून ते आलं असं कधीच होत नाही. राईट. म्हणजे 10 वेळा कॉइन उडवल्यावर 9 वेळा तुम्ही जर का परफेक्ट सांगितलं की हेड्स येणार का टेल्स, तरी सुद्धा 10व्यांदा ह्याची काही गॅरंटी नाही आहे की तेच येईल. राईट. मग आता समजा या दोघांपैकी कोणावर तरी तुम्हाला बेटिंग करायचं आहे. कॉइन टॉसिंगच्या गेममध्ये या दोघांपैकी कोणावर तरी बेटिंग करायचं आहे, तर तुम्ही कोणावर बेटिंग कराल? डेफिनेटली ए वर. का? कारण आत्तापर्यंत त्याचे प्रिडिक्शन्स कमीत कमी 90% तरी बरोबर आलेत. बरोबर. पण याची काय गॅरंटी आहे का की 10व्या वेळेला पण तो बरोबर असेल? नो. याचं फक्त 40 times आत्तापर्यंत प्रिडिक्शन्स परफेक्ट आले आहेत, पण तरी सुद्धा मेन गेममध्ये याचे 10च्या 10 परफेक्ट येऊ शकतात. पण तरी सुद्धा आपण बेटिंग ह्याच्यावरच करणार. वाय? बिकॉज हिज probability of winning is very high. Right. This is we are doing from the past experience or past readings. So this branch of probability is used along with the many branches like statistics and many other branches in science also, in maths also. So probability is one of the important branch of mathematics. Rather, it has become important in mathematics. Now गॅम्बलिंग पासून मॅथमॅटिक्स पर्यंत आलं कसं हे? लेट अस सी दॅट इन 1654 Chevalier de Mere was a French gambler and an amateur mathematician. Now he put forward one question or one problem to famous mathematician Blaise Pascal, okay, about some gambling, that what are the chances, what are the chances, what are the probabilities. And then the Blaise Pascal discussed the same problem with the Fermat, another mathematician, famous mathematician. And as a event or as an outcome of this discussion, the branch of mathematics, a new branch of mathematics, probability came into picture. इथे त्याची फक्त स्टार्टिंग झाली होती आणि नंतर पुढे जाऊन फिशर, बर्नौली आणि डिमॉयवर या सायंटिस्टनी ही ब्रँच पूर्णत्वाला नेली. Still we cannot say it is very complete branch, because mostly all the readings, even whatever the outcomes of this probability, is not 100% correct, is not sure. But still we have to believe in something. We have to take our decisions based on some probability or some statistics, and here the branch of probability helps us. Now let us learn what is the probability, and let us learn what are the different terms of the probability, what are the events, and how the probability of certain events are found out. Okay, so let us first see the terminology of the probability. Now whenever you do experiments in the laboratory, science lab, you know what is the outcome, right? For example, if you combine two chemicals, or if you do some reactions, you know what is the outcome, what gas will evolve or what chemical will form. You know all these things. That means the results are already known. But this is different in case of tossing a coin. Whereas you know the sample space, you know, that means what will be the results, you know, either head will come or tail will come, but you are not sure whether head will come or tail will come. You toss the coin 100 times, maybe all the 100 times tail will come, but 101th time head will come. So these experiments are done randomly, whereas the outcome is not known, or you cannot definitely tell us what is the outcome. Such experiments are called as the random experiments. And what are the definite outcomes, what are the possible outcomes are there, that is called as the sample space. So in short, we can say that the set of all possible outcome of an experiment, or rather of a random experiment, is called as sample space. Okay? So we are, in this case, we are going to see the particular events or particular experiments, like tossing a coin, tossing two coins, tossing three coins, or rolling a dice, rolling two dices, or we can take an experiment of taking out the colored balls or the cards, playing cards. Now these we are going to see. So let us first see what is the sample space. Okay. Now suppose if I toss a coin, what will probable outcome? What is the sample space? Either heads will come or tails will come. So this is a sample space. The sample space is denoted by letter S or omega. You can either denote it by omega or S. So this is called as the sample space. Now if you toss two coins, now mind well, if I have two coins, I can toss one coin at a time, then second coin, or I can toss both the coins at a time. The results or the sample space will be same. So this is a sample space for one coin. Now suppose there are two coins, what will be the sample space? Sample space will be either both will be heads, either this will be heads and tail, or it will be tail and heads, or both will be tails. If you toss two coins, so what will be your number of outcomes in the sample space? Here are two. So I can write here ns equal to 2, and here I can write ns equal to 4. Now let's take one more example of throwing a single dice. You know that the dice is generally a cube. There are 6 faces, so there are 6 numbers 1 to 6. Now suppose one dice is thrown, what probably you will get, or what definitely you will get? What will be the sample space? Exactly, it will be 1, 2, 3, 4, 5 and 6. If you toss one die, so what will be my sample space? That is 6. So ns equal to 6. The number of elements in this set, sample space set, is 6, right? But now if you toss 2 coins, but now if you throw 2 dice, then what will happen? Then your sample space will be very long. Like it will be either 1 1, 1 2, 1 3, 1 4, 1 5 and 1 6. Okay, what more can be there? Now this one will be replaced by 2. There will be 2 1, 2 2, 2 3, 2 4, 2 5 and 2 6. Then there will be 3 1, then 4 1, then 5 1 and then 6 1. And up to here we can write 3 2, 4 2, 5 2, 6 2, 3 3, 3 4, 3 5, 3 6, then 4 3, 4 4, 4 5, 4 6, then 5 3, 5 4, 5 5 and 5 6, and at last 6 3, 6 4, 6 5 and 6 6. So this will be my sample space if 2 dice are thrown. How many, what will be the ns for this? The number of elements in this set will be 6 into 6, that is 36. So here are the ns equal to 36. So this is a sample space. Now suppose there is a pack of playing cards. You know how many cards are there. There are 4 types of cards: heart, spade, diamond and club. Out of which spade and club are black and diamond and heart are red. Then there are 2 to 10 and joker, queen, king and s. These 4 cards are there, out of which joker, queen and king are called as the face cards. Mind well, ace is not a face card. Okay. Now if you take one card out of the pack of playing cards, how many cards are there? 52 cards. I am not counting joker. There are 52 cards, and if I want to randomly draw one card, what will be my sample space? Sample space contains 52 elements, right? And drawing one card is another event. Now throwing dice is an event. Now this is a total outcomes, total number of outcomes. Now what is event? The event is a subset of the sample space. That means suppose one dice is thrown. Now the event is, the number is even number. Now how many even numbers are there? 2, 4, 6. 3 even numbers are there. So A is the event of getting even number. So NA is equal to 3, 1, 2 and 3. Now suppose an event in this is getting same number on both the dice. How many? What is the possible event? This 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6. Only 6 possible events are there where on both the dice the number will be same. So this is one of the event. Now that event is a subset of the sample. Now that event is a subset of sample space. So a particular experiment is called as the event, which will be the subset of sample space. Now let us learn the types of events. There are different types of events. So let us learn the different types of event. For that we will take an example of one dice. So for the one dice, my sample space is 1, 2, 3, 4, 5 and 6. My NS is equal to 6. Now the first type of event is certain event. When you call a particular event as a certain event, when that event, now suppose A is a certain event. A is a certain event. If A has all the elements of your sample space, like if A is equal to 1, 2, 3, 4, 5, 6, that means your A is equal to S, then this kind of event is called as the certain event. So your NA is equal to NS, so this is called as a certain event. Let us see another type of event. Now suppose if I say that A is the event in which number is less than 10, all the number comes in this 1 to 6, so this will be called as a certain event because this set and this set are same, right? So let us see the next event, which is called as the impossible event. Now you must have understood what is impossible event. Impossible event means such a event. Now for example, if my event B is such that I should have number greater than 7. Now you know that there are only 6 numbers on the dice. So greater than 7 number arising this event has got no chance. That means your set B will be empty set and NB equal to 0. So this is a empty set. This is an impossible event which is not possible, which is not available in your sample space. That is called as a impossible event. The third type of event is elementary event. Elementary event means there is only one element in the set. That means if C is the elementary event and suppose the C is the getting number divisible by 5. So in this set, amongst this, there is only one number. So C is the elementary event. But suppose if I say the number is divisible by 2, then there will be 2, 4 and 6 will come in the set. More than 1. So that event will not be an elementary event. So we have seen 3 types of events. The first is your certain event, whereas your sample space is exactly equal to your event. Second, we saw impossible event. This is the event which is impossible. The set is empty, null set. And elementary event, whereas in this set only one element is there from your sample space. So these three are the events. Now let us see some more terminology of the probability. Now let us see what do you mean by complement of an event. Suppose event A is such that there are all odd numbers, that is 1, 3 and 5. Okay, sample space is 1 to 6, but event A is such that all odd numbers are there. Okay, now this event A is a subset of S, right? But are all the elements are A are there in this? Yes. But some elements are there which are not there in A, though they are there in S. Okay. So these remaining element, the set of these remaining elements is called as complement of A. And complement of A is written as A dash. So what are the remaining elements are there than A is called as a complement. So 2, 4 and 6 is also subset of S. Okay, so this set is called as a complement of this. And if you take the intersection of these two sets, that will be 0. Okay, no two numbers are common in this, right? So this is called as the complement of the sets. So now we have seen this is the complement. Okay, now what is exclusive? What is a mutually exclusive event? If two events are there and there are totally different elements are there, that means look here, A and A dash, there are totally different elements present in that. The intersection of these two sets is null set. So when such thing occurs, that all the sets, whatever, suppose now here only two sets are there, but suppose three events are there, in all three events there are no common elements, then such sets are called as mutually exclusive events. Okay, so we have seen the complement, we have seen the exclusive events. We are going to make use of this further. Mind well one more thing, two complementary sets or two complement events are always exclusive, but the contrast or the vice versa is not true. That means, as I said, the vice versa is not true. Suppose my B, event B has got only 1 and 3 and C has got 2 and 4. Now these two are exclusive events, right? These two are mutually exclusive events, but they are not complementary, right? They are not complementary because if this has to be complementary of B, then it should have all the elements except 1 and 3. That means 2, 4, 5, 6 must be there to become a complementary of B. But in this case there are only 2 and 4 are there. So though these both are mutually exclusive events, those are not complementary. Okay, but two complementary events are always exclusive events. Let's go ahead. Now at last we'll see what is exhaustive events. In case of one dice, suppose my A is 1, 3 and 4 and my B is 3, 5 or 2, 3, 5 and 6. If these are two events, I am not giving any condition at this moment, just consider that this is one event and this is another event. If the union of these two sets is your sample space, then these two sets are called as exhaustive events. Means if you combine these two sets, you will get a sample space. I said union, let the 3 be common, doesn't matter, that will come only once when you take the union. Okay, so these are called as the exhaustive. So these are called exhaustive events. Now let us solve some examples on this. Now before going to examples, solved examples, let me remind you, we have seen the complementary events. Okay, you know that the complementary events are exclusive events and also they are exhaustive events, because when you combine two complementary sets you will get the sample space, right? So let us solve a few examples on this. The first example is, two coins are tossed simultaneously. Write the sample space S, the number of sample points Ns, and then write the following events using set notation and find the total number of elements in each of them. Now two coins are tossed. So let us first, as they are asked, write the sample space S. The sample space S will be H T T H H H and T T. This is our sample space when two coins are tossed, either heads and tails or tails and heads or both the heads or both the tails, right? So what will be the number of elements? Ns equal to 4. A is the event of getting at least one head. A is the event of getting at least one head. That means there can be more than one head. So at least one head means 1, 2 and 3. So A is HT, TH and HH. So NA equal to 3. So we have A is the event of getting at least one head. Now let us see what is the B. B is the event of getting exactly one head. That means we don't want two heads here. We want only one head. Where we'll get? First two cases. HT or TH. So my NB is equal to 2. So B is the event of getting exactly one head. Let us see. C is the event of getting at the most one tail. Maximum one tail, not two tails again. Okay. C is the event of getting at the most one tail. But when they say at the most, that means if no tail is there, it is permissible. It is accepted. So HT, TH and HH will be there in set event C, where at the most one tail is there, two tails are not allowed. Okay, so my NC is equal to 3. D is the event of getting no head. D is the event of getting no head. That means we have only one event, one sample point, that is TT. Here no heads are there. So my ND is equal to only 1. Now we have to find out which of these are complementary events and which of these are exclusive event. Complementary event means the union, we must get the sample space. What are the events? Can you see there are 4 sample points are there. So we have first and D. So A and D are complementary plus exclusive. Why exclusive? Because the elements are not same, are totally different. But if you see HT is there, here also HT, these two are not exclusive, right? Let us see about B and D. Now in case of B and D, these two are exclusive, but are they complementary? No, because by their union you will not get sample space, right? When you add these two, B and D, if you are not getting a sample space, that means they are not complementary event, but they are exclusive events. Why? Because elements are different. In both the sets, elements are different. So we can say that B and D are exclusive events. But they are not complementary events, right? Let us see one more example. Now in this example, there is one bag, and in that bag there are 50 cards numbering 1 to 50. There are numbers written on those cards 1 to 50, like you have those housey cards and all those things. So what is my sample space? Sample space is equal to 1, 2, 3, 4, 5 and up to 48, 49, 50. So my NS is equal to 50. Number of elements in sample space are 50. These are the number of cards. So what they ask further, write the sample space S that we have written, write the event A and B and find the number of sample points in them, where A is the event that the number on the card is divisible by 5. What will be there in A? What are the numbers divisible by 5? So we have 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50. So what will be my NA? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this case, the number divisible by 5, my NA is 10 and this is my sample set. B is the event that the number on the card is a prime number. So B is the event of prime numbers. Prime number means the numbers, that particular number is divisible only by itself, none of the other numbers. So we have 2, 3, we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, then we have 31, 37, 41, 43 and 47. So we have, what will be our NB is, my NB is 15. You can write on the next line, no need to write on the same line. Now they are asked, also examine whether event A and B are complementary events or mutually exclusive events or both. Let us check if they are complementary event. Is their union gives you the sample space? No, not at all. So these are not complementary events. But are they exclusive events? That means no element is common in them. That is also not there because phi is common. So these two events are neither complementary nor exclusive. Okay. Let us see one more example. It says that there are 3 boys and 3 girls. Let me write 3 boys, B1, B2, B3, and there are 3 girls, G1, G2 and G3. Okay, this is the group. An environment committee of 2 is to be formed. An environment committee of 2 is to be formed. That means only 2 members will be there from B1, B2, B3, G1, G2, G3. Okay, let us see what they ask. Write the sample space S. Now what will be the sample space from this? Sample space will be either B1 will be with these 3 girls, G1, B1, G2, and B1 G3, or B2 will be with these three girls, B2 G1, B2 G2, or only two boys and two girls are also possible. So there can be B1 B2 or B1 B3 or B2 B3. Similarly, only two girls is also possible combination. That means we will have G1 G2, G1 G3 and G2 G3. So this is my sample space. How many readings we have? 12. So my NS is equal to 12, or B1 can be, B3 can be there with G1, B3 G2 and B3 G3. So this is the combinations of one boy and one girl, but it is possible that there are both the boys or both the girls are there in that committee. So we will have B1 B2 or B1 B3 or B2 B3. This is the possible combination, or G1 G2, G1 G3 or G2 G3. This is the possible combination. So this is my sample space. There are 15 points, that is the 15 elements. So my NS is equal to 15. Now let us say what other events they are asking for. A is the event that a committee should contain at least two girls. A is the event of at least two girls. In that case, there are only these three events where at least two girls are there. So here will be, this will be my event A, and my NA is equal to 3, which is G1 G2, G1 G3 and G2 G3. Correct? What is B is the event that the committee should contain both boys. Both boys must be there. Similarly, so B has both the boys. So I think this is my event B. B1 B2, B1 B3 and B2 B3. In this case also my NB is equal to 3. Are you getting these points? C is the event that a committee should contain only one girl. Now only one girl means these two girls are not allowed. Two boys also are not allowed. Only one girl. So these 9 elements will be the set of, will make a set C. Only one girl, so my NC will be equal to 9. This is my event C will be there. Only one girl. The D is the event that there is at the most one boy in the committee. Maximum one boy in the committee. Maximum one boy, here are two boys. Not possible, two boys are not allowed. At the most one, maximum one means if there are no boys, it is allowed. So we will have this 9 plus this 3. So we will have, my event D will be the combination of addition of A and C. Right? These 9 readings or these 9 elements and these 3 elements. So my ND will be equal to 12. Now they are asking, find the events among the events defined above. That means in these events which are complementary events, mutually exclusive events and exhaustive events. Now here A and B are exclusive events. B and C are also mutually exclusive events. Then D and B are also mutually exclusive events because no elements are common in this set. That means, let us write here, A and B are exclusive events. A and B B and C, B and D are mutually exclusive events. Why? Because the intersection of these sets will be null sets. That means and because the intersection of these are null sets, all the elements are unique in both the sets. Okay, now let us see if we have any complementary events. Now we know that A and C, this A and C combines D, now only B is remaining. Okay, so A, this D and B, these two are complementary events. B and D are complementary events. That means B, this D is equal to B dash. How can I say that? That means this D is equal to B dash. This is the complement of B. Why I can say that? Because when you combine B and D, you will get S. When you combine B and D, you will get sample space. Are you getting this? We know that A and C is combining making D. So A and C are making D. What is remaining? B. So if you combine all these three, you will get the sample space. So D and B combined becomes complementary. These two are complementary and also exhaustive. What do you mean by exhaustive? If we combine both the events, if it becomes a sample space, that is called as exhaustive. So this is how you are going to solve the problems on probability. It is very simple, very simple rather. You have only 1 coin, 2 coins, 1 dice, 2 toys, then something like this, 2 boys, 2 girls, or 2 men, 3 women, or you have 3 colored ball, 3 red ball, 4 green ball, and you have to pick up 2 balls, something like that. Or you will have the playing card pack. So these kind of problems are there in your exam. Let us see one more example of 2 dice. Okay. Now when 2 dice are thrown, we have the sample space this, and we have NS is equal to 36. Now let us see what they ask more. 2 dice are thrown, write the sample space S, which we have written, and the number of sample points NS, the number of sample point is 36. Write the following events using set notation and find the total number of elements in each of the following events. First event is the sum of scores on the uppermost face is multiple of 5. Uppermost means whatever number you get by throwing 2 dice. So the addition should be, or sum should be, multiple of 5. So my first event is, I can say A, the addition must be multiple of 5. What is the maximum sum we get? Here is 6 plus 6, 12. So we have multiple of 5 means 1 and 4, 2 and 3, 3 and 2, then 4 and 1 is also 5, then 4 and 6, 10, which is multiple of 5, then 5 and 5 is 10, and 6 and 4 is 10. So let us write down the elements of A. We have 1 4, 2 3, 3 2, 4 1, 4 6, 5 5 and 6 4. So we have NA is equal to 1 2 3 4 5 6 7. The second event they have asked, the sum of the scores on the uppermost faces is 20. The sum is 20. Now suppose B, the sum is 20. We know that when 2 dice are thrown, the maximum sum is 12. So this is empty set, null set. And NB is equal to 0. The third is, the score on the first die is less than the score on the second die. So we have, let this event be C. So we have 1 2, 1 3, 1 4, 1 5 and 1 6. From the second row, we will have 2 3, 2 4, 2 5 and 2 6. 2 3, 2 4, 2 5 and 2 6. From the third row, we will have only 3, 3 4, 3 5 and 3 6. Fourth row, we will have 4 5 and 4 6. On the fifth row, we will have 5 6. And on the last row, we will have nothing. So here we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So NC we have 15. Next is, let us see event D. The sum of the score on the uppermost faces, sum of the score is perfect square. Now we know that what perfect square we have in this. We have 4, 9, after that 16 and 36. So the addition should be this. So we have 1 3, then 2 2, in third row we have 3 3. The sum is 9, in this case 3 3, and 3 1 also we have, because addition is 4. Then we have 9 is 4 5 we have, 4 5 is 9, then 5 and 4 is also 9, 6 and 3 is 9. So we don't have 36 at all there. We have only up to 9. 4 and 9 are possible, because 6 plus 6 is 12. So 16 and 36 are not there. So we have only 4 and 9, and we have 1, 2, 3, 4, 5, 6, 7. So my ND equal to 7. Then they are asked, find the events among the events, complementary events and mutually exclusive events. Now if you see, there are no complementary events. No complementary events are there. All the events are different. Okay? No complements of each other. But exclusive events, yes, we have exclusive events. We have A and B are exclusive events. Then B and C are also exclusive events. Then DB and DA, DB and DA are also exclusive events. Why? The intersection is null set. So this is the answer. This type of questions are there for your exams. Extremely easy. Just you have to write this properly. Sets are to be written very properly, and then you have to find out the events. You have to write the set of the event, then you have to find out the number of elements in that event. So is the case. Now we will go to exercise 4.1. So friends, we have learned this topic thoroughly. We have solved some examples for practice, but we are going to solve all the exercises which are given in the book along with the problem set, then the HOTS, some paper solutions, everything we are going to solve. For further solution of exercises and problem set, please purchase our DVD. You can buy our DVD online by visiting our websites. The address for the websites or the place where you can buy your DVDs are given just below this video in the description. Thank you very much.